Welcome. Mic. One minute. Over. Final adjustments. Mic I will put. Okay, I will remove that one slightly down. Nothing to worry. I will shift it down to workspace. Okay, here. Okay, no problem. I will slightly shift it so that screen is fully visible. Some slight shifting I have done. Okay, I will rewrite the section. Because now I will tell you, ready for public. That is, who are not coming to any of my class earlier, my class will start now. Because my commitment is what? Explain how to design the column subjected to axial load and biaxial bending, in between uniaxial bending. Okay, 1 minute. Charging everything okay? I'll just check everything. Because I don't want once again charging okay. Same thing, by chance, due to any reason, if there is a problem, wait for 10 minutes. Okay, this is continued. Okay. Screen is vertical. 718. Now see, now screen okay. Just tell me, is the screen okay now? Is the screen okay? Not okay now. Why? Screen is vertical. No. I have gone for orientation. 1 minute, I'll check it. I have gone for orientation. Lock orientation. Okay. Some settings solve problem. 1 minute. Rotate the device. It is telling rotate the device. Now if I rotate means problem. 1 minute. I rotate it. Okay. Once again rotate it. Okay. What about now? Tell me. What about now? These settings all I have learned. What about now? Is screen okay now? Is screen okay now? Is screen setting? Yes, okay now? Okay, thank you. Finally. I removed and rotated once. Okay, thank you. Okay, I will see the restricted space. See, I am not going for further setting now. Is the board fully clear? Any outside thing is visible? Tell me. Any outside thing visible now? Little no problem. Little okay. Outside disturbance too much is not there, no? No, okay. See, okay. I will go for higher mode because even here also I am not seeing the setting. Auto, advanced setting, 480. Okay. I am going to 480 now. Because it's not 480, that's why it was coming slow. Now it's clear. Okay. Okay, let's start. What happened? Screen rotated once again. What is the problem? Screen once again rotated. You told everything is okay. I will check. Screen blur. I don't know what is the problem for the settings or. Earlier it was okay. Okay, 1 minute. I will remove that screen rotation. 1 minute. Lock orientation. Bluetooth KSN. Okay. This one is okay. Geo. Lock orientation. Screen rotated by 90 degrees. Sorry. I don't know these things, why it's giving trouble, I don't know. Now okay. I turn by 90 degrees. Just tell me, now okay. Is now okay? Not okay. Now, what about now? Not okay. What is the problem for this one? It is telling rotate device. I will. How to rotate device? 1 minute. These minor problems only give troubles. I don't know, someone should be there to set it. If someone, I should ask someone next time to be ready here, who knows all these things. At least hope now it is okay. At least hope now it is okay. No comment. Okay now? No. Someone wrote okay there. No problem? Okay. Thank you. Luckily. No problem? Okay. 1 minute now. I am not going for any further setting now because the screen turning become problem. So what I will do is, don't worry, these are all only for 1 week or 2 weeks, that's all. Only for 1 or 2 weeks. Once it get, I set for it, I should know actually what is the problem first of all. Main problem is the problem faced. Camera, I am not expert like you. You are all expert in camera. Oh, see this mic has some problem now. 1 minute. It fell down here. A part of mic fell down. Where? 1 minute. I just set the mic there. Okay. One problem is for that. Okay. Now I'll manage. Again, inverted. It should have come from other side. Small mistake means see how much problem. Now don't tell me screen not okay now. Horrible it will be for me. Top screen vertical. In laptop screen vertical. Okay. I'll continue. So don't see laptop now. Time being. How much time I can adjust it? I cannot keep on adjusting here. Right now. Second part see in mobile only. What orientation problem? These people, I don't know why they are doing that way. Lock orientation. Okay, lock orientation. How is in laptop now? Tell me. How is in laptop now? How is in laptop now? Okay, something. Vertical. Okay. I'll remove once again the orientation. Lock orientation. Okay. Now go through mobile only now. Remaining half, what to do? Go through mobile only. If mobile okay, we shall continue. Because, okay, at least first half you saw through laptop. Right now what to do? We can't waste time like this. Now, mobile okay now? Okay, I'll continue. Go through mobile only, at least. Little time through mobile, later you see. Okay, now, see. So what happens is, such things actually removes the seriousness. At least tell me, voice clear? I have not asked you. Is the voice clear? That is the most important. Voice clear? Voice. Okay. See, now correctly understand. I will start once again from here. See, so that I will make, see, those who joined late, those who are newcomers to me, those who by YouTube link or someone you got, your class starts now. There is a column, see, of cross section. I should again see the 1 minute here. I should see that writing is visible here. That was equally important. Okay. I will see here now. Something man. Actually, such things actually makes frustration. There is a column of cross section here. See, I write here. Take words now. Those who are, imagine I am giving the same question by words now. How we arrived here, that is structural knowledge, which I explained for regular students. Others get benefit from it here. Now our design starts. A column has one side 350 mm. I won't write mm. Understood. Other side 550 mm. Okay. Here, this is a column cross section. You have to use M20 concrete and FE 500 steel for design. Then factored axial load PU equal to 2400 kilonewton, and design for axial load with, remember, axial load with, not biaxial, axial load with uniaxial bending. Uniaxial bending twice. Design for axial load with uniaxial bending twice. That is, I write here, that is once. Right time only, that ink problem. That is once. That is one case. Case one. Case one is PU equal to 2400 kilonewton and MU equal to factored MU of 70.82 kilonewton meter. How? For the cross section, it is PU here. And for this MU, remember, I told you repeatedly for you 100 times. For this bending moment, this is the structural depth. This is structural depth equal to how much? 550 millimeter. And width is secondary, right here. Structural width B equal to 350 millimeter. Therefore, I told you that PU is here, that MU is like this. That MU is like this means, remember, it is about this axis. This is the axis, only one axis. Don't tell what, 1122, just axis. So, PU equal to 2400 kilonewton, a bending moment of 70.82 kN meter. One side is 350, other is 550, M20 concrete, FP 500 steel. This is the design. Okay, PU is here. Now, for this bending moment, structural depth is 550. This is one of the design. Okay, now, second one, I write here. And second design is, say, PU equal to 2400 kilonewton only, and your mu equal to how much it is? 70.8, 48.17 kilonewton meter. Once again, axial, the second one, axial load is uniaxial kilonewton. Cross section is like this. This is a cross section. This is 550. This is, I write here now. This is your 350. This is structural depth is 350 now. Structural depth is 350 mm. This is the structural breadth equal to 550, and load is here. Now bending is like this mu. There this way, here this way, mu. This is the second case. Now these two design you require. If these two are fully clear, you can easily design column with the column with axial load with the biaxial bending, because even when you go to biaxial load bending, the design is actually combination of uniaxial. See now, axis, see, when the bending is this way, this is your axis. See, I told you, bending is this way means this is your axis. These all I told you in the earlier classes. Or for you, this is a question. See, start. Now, systematically start. Two separate designs. So learn, because when you go to design of column with the biaxial bending, there also you have to do uniaxial twice. But little changes are there. I will tell the changes. Everything visible here? Why? Yes. I want live chat actually. Hope there is no problem. Who is out of screen? I am out of screen. I am here only. Who is out of screen? Someone commented out of screen. I went out of screen most probably for writing there. For writing there I went out of screen. I am in the screen only now. Everything clearly visible now? Tell me. See, such things all don't give too much important. Learning should be more important. Left side. Okay, I'll check there. Left side out of screen. It is visible? No. Okay. Slide tilted. Okay, no problem. Now left side is fully okay. Okay, I tilted. Maybe it's little turning. Now left side fully okay now. Now left side fully okay. Okay. Start. See, correctly observe now. How to design you should know. I will tell one by one principle. Open. See, first. Now this is a new thing. See, my class for general public starts now. Start any of these two. I will start case 1. This is case 2. Case 1, case 2. Okay, case 2. Start case 1. Case 1. Now you should write some note. What all I dictate here, you should make a note if you want to learn thoroughly. Not simply keep quiet and expect everything to be done by me. When you want design the column with axial load and bending, either uniaxial or biaxial, two terms are coming. One of the term is PU by FCKBD. BDDB no problem. And second term is MU by FCK BD square. For PU area, for bending section modulus. These are the two terms you require. Now see here. You know PU for both the cases. You know MU for both the cases. FCK is known. I write here. See, M20 concrete, FCK equal to 20 Newton per mm square. And FE 500 steel, FY equal to 500 Newton per mm square. Remember. Therefore, you know FCK. And B and D are written here. When I go to case number 1, I told very clearly My PU is how much? My PU is 2400 kilonewton. Convert to Newton, 10 to the power 3 Newton. And my MU is how much? 70.82 kilonewton meter into 10 to the power 6 Newton millimeter. Okay. PU MU over. Then, and also very important, structural breadth B equal to, see here, for this bending, structural depth is 550, structural breadth is 350 millimeter. And the most important term, structural depth. Depth is the important criteria. Structural depth equal to 550 millimeter. Okay. Now, you need one more term called D dash. See, some space is there. I will go left side now. Hope some space is there. If some space is there, oh yes, some space is there, I can use it here now. See, now you need a term called D dash. I write here. D dash. D dash is effective cover to reinforcement. Effective cover to reinforcement is called D dash. Fully visible? Just, if not visible, tell me immediately. Effective cover to reinforcement. Effective cover to reinforcement, that is D dash. Any border problem is there? Here what happens is I can see screen partially. That is the main problem. Not fully visible. This is rotating like anything. This deserves to be kicked out. This see. Going here, going on mate. These YouTube people should do something at like Zoom. They don't give importance to that overlapping all. And cloned app. If I want to go to that one, I have to wait for some time. Effective cover to reinforcement. That is called, I won't see comment now. See, comments are required because otherwise how I will not be knowing any problem is there or not there. Okay. Okay. Effective cover reinforcement. Remember, one sketch I will write, remove it now. See, this is the column, cross section. Make a note. I do not know how many bars are there. I will just put randomly some 8 bars here. I will put this way reinforcement. Now, this is called clear cover. Clear cover. Take clear cover equal to, under normal cases for column, that all we can't discuss here. That I will tell in the ETAP safe class regarding cover requirement when you go to building. For a column reinforcement, remember, the clear cover is minimum 40 mm. Remember, make a note. Under normal cases for a column, minimum clear cover is 40 mm. Make a note. Now, D dash means, see, from the extreme edge up to this. See, remember now, when this is D, along D, this is corresponding D dash. Whereas, when you take, if this is D, that is D dash. Whereas, see, suppose, imagine, this is your D. If this becomes your D, then this all I am removing now. Along that D, this is called D dash. I will put correct color. See, D dash. This is your D dash. That is, along the depth, extreme end up to center of steel is D dash. Whereas, remember, what we will do is, we will take diameter of bar, we have to assume. For columns, under normal case, usually you should not provide diameter less than 12 mm. Some other requirements are there, I will tell you later. But 12 mm is too small. Do one thing, safer side, take little bigger. So safer side, say, I will take 25 torr. Because my load is 2400 kilonewton, it's not a small load. It's a heavy load. I will take 25 torr. If I take 25 torr, then whether it is here or here, remember, for both the cases, your D dash will be clear cover of 40, answer you have to give, plus half of 25. This much common sense you should be knowing. If you don't know the effective cover calculation, you should not have come to my class for column design. Go to 5th semester B, start RCC there. So it will be 52.5 millimeter. So whether it is this way or this way, your D dash effective cover is 52.5 millimeter. So I will do one thing now. I will write here only common data. You write all those things and write your D dash equal to common here, right? Common for both. Your D dash equal to 52.5 millimeter. Okay. Explanation I just now gave for you. So now make all these notes and get the value of D dash. Okay, start. Now, first you have to find, now what all you require. When you design for axial load with the uniaxial bending, that is PU with the MU. See, if it is PU with the MU1 and MU2, there also we are splitting. Once PU with the MU1, once PU with the MU2. So there also you get same thing. Then you have to link it by alpha n. Some linking is there. Practically linking will be there. Here no linking. So what you require is, first you require D dash by D or first you decide D dash by D. D dash by D equal to 52.5 is D dash. D is 550. See, D is 550. Answer. D dash by D comes to 52.5 by 550. 0.095. It comes to 0.095 D dash. Now, make a note. We have to go to interaction diagram in SP16. So many diagrams are there. I will tell you how to search it. So many diagrams are there. Okay, now, in the interaction diagram, they are not given D dash by D equal to 0.05. They, in the SP16, in the interaction diagrams, they considered D dash by D equal to D dash by capital D equal to 0.05, 0.10, 0.15 and 0.20. These are considered. Now, remember, what we have to take, whatever you got here, better round up to next number. Remember, as D dash by D increases, it means column becomes weaker. Y means common sense knowledge. As D dash by D increases, that is more and more cover, column becomes weaker. And design case, you should design so that column is weaker only. So remember, always round off or consider next number available in SP16. Therefore, tell me answer. Consider. But one thing, if you get 0.103 like that, you can take 0.1. Therefore, consider D dash by D equal to, tell how much you will consider, tell the answer. We got 0.095. See, these are the four numbers available in SP16. Tell me how much you have to consider now. We will consider 0.1. Okay. Nobody should question now. 0.1. Okay. Now, D dash by D over. Now, immediately go and decide what is the chart number and also page number if you want. Page number in SP16. See, chart number is, first they told, see, you have to go for, where is the SP16? Oh, my SP16 is inside. I will get it now, because why? I should read it in front of you. I know the chart number. I should read it in front of you. 1 minute. I will get it. I will read SP16 in front of you. See, I am explaining very systematically and I am losing lot of my time. If I wanted, I can finish fast. No, when I do something, I want it to be useful for each and everybody. At least they should tell that the class we attended helped us a lot. That feeling should come. See, open SP16. See, I'll tell you page number all. First, compression members. Page number I don't know. Halfway through compression members. Then page number 99 it starts. Page 99 compression member detailing starts. They told axially loaded. We don't want it. Go further. So many things you can see there. They have proved SP16 charts. See, then page number 109, they told pure axial compression. No, we want to design for axial compression with bending. So no, go further. Then after pure axial, see, then you can see page number 112, compression with bending. Rectangular section. See, page number 112, I will not repeat once again. Page number 112 in SP16, chart number 27, they told compression with bending, rectangular section, reinforcement placed equally on two sides. Practically, equally on two sides, nobody gives. Actually, equally on four sides also not possible. That's a problem. It's a serious problem. So, practically what people do is, they consider reinforcement what? Tell me, equally on two sides or equally on four sides. Equally on two sides is stronger case. Equally on four sides is little weaker case. Safer side, they take weaker case. Therefore, tell what they refer. Equally on two sides or equally on four sides. Decide now. Everybody, same thing they are doing. Tell me, they are considering equally on two sides or equally on four sides. Fast. Which one they are taking? Equally on two or equally on four? You have to answer at least. I told the reason now. Further reason I can't discuss. Something you tell, correct or wrong. Equally on two side means, I will tell you what. Equally on two side means, see, I will tell you what is that one. If the bending is this way, only here, see this way. Whereas, if the bending is this way, if the bending is this way, only here. This way. This is equally on two sides. Equally on two sides, nobody considers. Do one thing, always consider equally on four sides. So, reinforcement you require equally on four sides. Equally on four sides. Okay, now, if you go to the chart number 27, page number 112 starts with reinforcement distributed equally on two sides. So, we want four sides. Turn the page. Go further. First you can see fully equally on two sides. Tell me which page number SP16 started equally on four sides. Tell the answer. Tell me. Which page number SP16 started equally on four sides? Tell the answer. Which page number SP16 started equally on four sides? Page number or chart number. Tell me. Which page number or which chart number SP16 started equally on four sides? Tell me. Chart number. No, tell me chart number. You turn the pages. Suddenly you can see compression member with bending, rectangular section, reinforcement distributed equally on four sides. Tell the chart number. First chart number. Don't see FCK, FY all. Tell the first chart number. They change equally to two sides to equally to four sides on which chart number? See, you are not answering. Which chart number? See SP16. See, you should have SP16 with you. At least someone should tell. Okay, I will tell chart number 39. Leave it now. But there it is for Fy equal to 250 Newton per mm square. Now, so finally, when I came to chart number 39, remember, go further, when I reach chart number 39, in page number 124, I finally got reinforcement equally on 4 sides. They started with the ascending value of Fy. First they told Fy equal to 250. No, our Fy is 500. So, turn the page. Go further, finally till you reach Fy equal to 500. The page number is chart number 47. See, your chart number 47, I'll tell you here, chart 47, chart 48, chart 49 and chart 50. Correct? Huh? Chart D dash by D. Yes. Chart 47, chart 48, chart 49 and chart 50. These are for Fy equal to 500 Newton per mm square. This is for D dash by D equal to 0.05. This is for 0.10. This is for 0.15. This is for 0.20. Remember, these 4 charts today in the group I sent for you. Yes or no? Tell me. In the WhatsApp group of the batch, for RCC batch, for steel batch, for basic structural knowledge batch, and also our batch, E-tab and SAFE. Today I sent the 4 charts. Did you receive it or not? These 4 charts I sent you today because I decided I will take Fy 500. I decided I will take Fy 500. Okay. These 4 charts are there. Now tell me. Now our D dash by D, you take 0.1. Tell me chart number to be considered by seeing here. First comment and tell me which chart number we have to consider. Which chart number we have to consider for this case now. For our present design of this D dash by D equal to 0.095 rounded to 0.1, which chart number we have to consider? Now, right now, which chart number we have to consider? Some idea? Tell me which chart number we have to consider now. Chart number 48. That's all. If anybody wants further explanation, you go to a better place who is better than me. That's all. So refer chart. Therefore, chart number 48 to be considered. Over. Considered. Now I will remove everything. Now remember now. In case afterwards you should tell if D dash by is rounded to 0.05, chart number 47. If you round up to 0.1, chart number 48. If you go to 0.15, chart number 49. When you go to 0.2, chart 50. Not only here, next for biaxial also. I will not tell at that time. I will tell chart number last class thoroughly explained. I will ask, tell me the chart number for Fy 500 reinforcement equally on 4 sides. Once I write D dash by D, accordingly you should comment and tell the chart number. Agreed? Now onwards, chart number you have to tell. Tell me, agreed or not? Agreed or not? First. Otherwise I stop the class. Chart number you have to tell. Agreed? I cannot keep on explaining this way every day. There is a limit. First of all, show a person who is explaining this much. Show a person. Okay, now start. What you require is, see now, the 2 parameters. First find PU by FCKBD and also find MU by FCKBD square. Okay, start. PU 2400 10 to the power 3 divided by FCK is 20, breadth B, structural B is 350, structural D is 550. I told you, when you find PU by FCK BD, hardly matters which is B, which is D. But it matters here, because why? Here structural D square is there. Here it matters. Oh. Tell me first answer. Answer first. Second decimal sufficient. Answer. second decimal or third decimal. Okay, tell me third decimal. Later round off. Tell me the answer. Third decimal. Third decimal. Just for a change. You later you go to second decimal. Just to understand thoroughly. Third decimal. 0.623. Okay. 0.623. Remember, this is dimension unitless. Why? PU Newton. Newton per mm square into mm square. Or numerator is the hitting effect. Denominator is resisting. See, numerator is hitting effect. Denominator is resisting capacity. So you always want denominator more, means section is stronger. Okay. Same way, mu 70.82 10 to the power 6 divided by FCK is 20. Structural B, now you should be careful. Structural B is 350 and structural D is 550 square. Tell this number. Tell this number also third decimal. Tell this number also third decimal. 0.033. Okay. 0.033. 0.033. Okay. Now, see what to do is, now see, referring to chart number, what? Chart number 48, we get P. I will tell you what is P. See, P. P means percentage of steel. Now, very important, when you should make it, I will tell you later, we get a percentage of P equal to this, you have to decide now. See, I will explain thoroughly only once. Second time, I will not explain. See, I will explain only once. Hold the SP16 chart. See, I put here. This is the SP16 chart. You can see like this, plenty of this way. See. Then finally, you can see outermost curves are there. 1 minute. Remember, tell me, PU by FCK BD more, MU by FCK BD square more means hitting is more. Good or bad? Tell me. Higher value is good or bad? Higher value is good or bad? Tell me. Common sense. This PU and MU are the action. How much is the axial load? How much is the bending? Good or bad? They are bad. If it is too bad, it can go out of this line. If it goes out of this line, then not safe, cross section to be what? If it goes beyond that line, cross section to be what? Tell me. If it goes beyond that line, cross section to be, it means unsafe. Redesign. Remember, you should always get within the intersection. Okay, start. Somewhere here you want. If it goes out of the chart, means, see, column is unsafe. Redesign the column. Either go to M25 concrete or M30 concrete, or take a cross section, not 350 by 550, 400 by 600. That way you require redesign. So you should always get inside. Okay, now see how to get. Along this line is MU by FCK BD square. Along this line is PU by FCK BD. Or along this way, x-axis, it's a bending effect. Along vertical, it is the load effect. Clear? Along x direction, bending effect. Along vertical line, along horizontal y line, it is a load effect. Clear or not? Along x is the bending effect. Along y is the load effect. Clear? Clear or not? This is not clear means, okay, clear. Now, start. First you do one thing, go along the load this way. See, start. 0.623. Exact 0.623 is not there. Remember, when you design for safety, better consider hitting effect, danger effect, slightly more or lesser. Tell me, when you consider here, exactly not possible. It is better to be little liberal, take little higher or lesser. Tell me, for safety of the column, when you design which are bad, better take slightly what? Which are bad, better take slightly. Exactly not possible. Slightly more. I told you repeatedly earlier in the regular class, something bad, safer side, take little more. When the expense you are planning, expense is bad, better take little more money. That way, you go along this line and somehow mark 0.623. Exact 0.623 not possible. Little what? Relaxing. Little higher, slightly more you can do. Approximately 0.623. I will mark now. See, 0.6, 0.7. This SP16 table, you cannot see values because Xerox copy. But if you got original sheet, okay. Today Tushar sent you, not he sent me, I sent you. In the those who are my regular students, in the group, I sent you SP16. Zoom it. In the WhatsApp it is sent. Zoom it. 0.623, 0.6, 0.7, 0.65. Okay. I finally decided the point somewhere here. Okay. I decided here. This is the point. This is the point for 0.623. Next time not explaining. Okay. Now tell it. Hey. Bande. Now go to mu by FCKBD square. That number is 0.033. 0.033 is not there. So 0, 0.01, 0.02, 0.03 is there. 0.033. Maybe I got somewhere here. So many lines are there. Somewhere here. Okay. Now this is for your 0.033. Remember, this is the case of lesser bending moment because only E minimum considered. When I go to column with the biaxial bending, this will come somewhere here. High bending will be there. This is initial. Now, directly go this way, you get an intersection point here. I don't know where it comes. You get intersection point. That intersection point, see here, one line you can see here, one line you can see here. Tell the answer. What you can see is all these lines, they told P by FCK, not P. They told P by FCK. Now tell me the intersection point lies between which two values of P by FCK? Everything you have tried today. Very slowly I am telling. After the class is over, through recording, repeatedly go through, understand, then remember for lifetime. Tell the answer. Tell me the two values of P by FCK between which our intersection comes. I cannot tell here. Not possible. Roughly I will tell you. .623. Is it between 0.04 and 0.08? No. Or 0.06 and 0.08? Is it between 0.06 and 0.08? I somehow feel. Yes, it is coming between 0.06 and 0.08. See, now, see correctly here. This is 0.08. This is 0.06. Now, point comes here, for example. Then, I think if it comes here, you can take 0.06, 0.07, 0.08, 0.07, 0.675. That way. Therefore, now, for safer side, little higher side. Tell the answer. So, if it comes here, maybe 0.06, 0.08, 0.07, 0.06, 0.0625, 0.065, 0.0675, maybe 0.0675 is my guess. That way, tell me, we get, I am removing everything now, we get what? I'll remove everything now. We get P divided by FCK equal to, tell the answer to me, referring to chart, decide and tell the number fast. How much? You decide. You decide and tell me. If wrong, no problem. You are learning. Later do correctly. These all practically you don't have to do. This everything E-tab will do it. See, finding PU by FCKBD, finding MU by FCKBD square, finding E minimum, deciding L effective by S, deciding short and long, deciding higher value, deciding effective cover. None of them you are doing. In the practical design, model, run, result, over. This everything, yes, but E-tab will do. But here, answer. You tell some number. Nobody should tell tomorrow a general public comment comes. In the class he wrote 0.0675. 0.075. Okay. 0.075. Okay. 0.075. Okay. Now, tomorrow, see, this class is public class. Somebody may comment. Sir, that reading of this is wrong. It is not 0.075. If you tell something, I will tell him, come in front of me and talk. After all, some number. These comments are not valid. I have not done it. See, I told the students to get it. What they told I wrote. You should practice. You should tell me if something wrong here or some principle wrong. Don't tell wrong for numerical values. Then you should have come to the class. No, I was not knowing at that time. Later I saw it. Then, so what? I thought that it is not 0.075, it is 0.085. Take 0.085. Why are you telling me? Why you are telling me? Take it then. My responsibility is to tell along the X line MU by FCK BD square, along the Y line PU by FCK BD, go this way, intersection point, see the two curves, and then between those two decide almost as accurately as possible what is the number 0.075. They told, I wrote, keep quiet, I will tell him. If at all he comes in front of me, he will not come. Okay. Now remember, this 0.075 is P by FCK, where P is percentage of steel. Therefore, P equal to what? 0.075 into FCK is 20. Tell the answer. What is the percentage of steel required? What is the percentage of steel required? 0.075 in 20. You want to calculate for that one? $1.5, correct? It is 1.5%. Okay, start. 1.5%. Now do one thing. You tell this one, Ayo, please wait. Please wait for some time. I will come back to you later. Now I will remove this side. No problem. This side I am removing because I am going to second design. Shall I remove this one now? Shall I remove this one? Shall I remove this one now? It is not required now. I wrote both the cases there. Can I remove this side? I want it to be there for some time. Can I remove this one now? Yes, okay. I will remove. Anyway, I will remember now. Values I may forget actually. Okay, no problem. I will still remove. Okay, see. I will write here only. See, these all not required now. Second one. Now do one thing. Come to case 2. PU is same. MU equal to, how much? MU? Oh, here. 48.17 kilonewton meter. Remember, now that MU is how? That MU is this way. I return. See, that MU is this way. MU. PU is here. Now remember, this is your structural D. This is your structural D equal to 350. This is your width B equal to 500, to 550. Okay, start. Once again, I remove everything now. Okay. B equal 550, 350. B equal to 550, 350. Now, start. Here. First find, see, PU by FC, 1 minute, before that one, first see your D changes. So D changes now. Therefore, first you find what is D dash by D. D dash by D is, I told D dash 52.5. Now your D is 350. Remember, D is 350. Therefore, tell what is D dash by D. You will tell after half an hour. Better I calculate. 350 divided by 52.5. 350 divided by 52.5. 52.5 I am getting 55 divided by 350. Point exactly 0.15. Correct? No. How it came? Exact number? How exactly came? Rare chance of getting exact. 52.5 divided by 350. Oh, exactly 0.15. Rare case. Okay, so what? It comes exactly 0.15. Therefore, thanks. Thanks. Why thanks? For giving exact number. Tell the answer. For 0.15, tell me what is the chart number. Tell me fast. Chart number, fast. For 0.15, chart number. Fast. I told you D dash by D for 0.05, 0.1, 0.15, 0.2, all I told. Chart number. For 0.15, chart number. First, chart number. Now chart has to be changed. It is not 47. 49, huh? 47, 48, 49, 50. What is chart number? For D dash by D equal to 0.15, chart number 49. Chart number is 49. So go to chart 49. See. Once again, PU by FCKBD, you need not calculate because it is once again 2400 10 to the power 3 divided by 20. Last time 350 by 550. Now it is 550 by 350. No effect. It will come same. How much? 0.623 will come. But remember, MU by FCKBD square, that will change. The FCKB D square, that will change. That will come MU. See now, this is the axis, remember. Now, MU, 48.17 10 to the power 6 divided by FCK 20. Now B is 550, D is 350 square. Fast tell this number also. Fast tell this number. You are making me to calculate by not giving the answer. How much time? See, once the lag is over, once I remove the lag, then if you don't give the answer, I will stop the class and take rest immediately. Now because of the lag, I am helpless. Is it 0.036? It is 0.036. Okay, 0.036. Now, do one thing. Refer to chart number. Yavadu? I told you. Now chart number, which one? Where I wrote? Chart, thanks. Chart number 49. Do the same way till we get P by FCK. Now tell correctly answer now. Along the X line, you go by, along the Y line, you go by 0.623. Along the X line, you go by 0.036. You go to intersection point, and by seeing the either side boundary value, tell me the value of P by FCK. Till you tell, I will sit somewhere here and wait. Why? Take rest. Not going outside. I will sit here and wait for your answer. I am not going to see SP16. Tell the answer. P by FCK you will get. Along the X go by 0.036 bending. Along the Y go by 0.623. Get the intersection point the way I explained just now. Then somehow decide the curve between the 2 points. Liberally tell what is P by FCK. What is P by FCK? Fast. I am waiting for your answer. See the chart and tell me P by FCK value. 0.078 okay, agreed. Someone tomorrow comments, no, wrong. If wrong, come to me in front of me and tell the answer. The moment he talks, I'll set him outside. I'll tell him, get out. 0.078. Therefore, tell what is the, this is the percentage required. What is the percentage required? Still 0.078 into 20. Answer. 0.078 into 20. 1.56%. You need 1.56%. Over. Okay. Now, everything is over. I am removing everything now. Tell me, so far what is done? How to use SP16 interaction diagram, and if you know chart number, comma, PU by FCKBD and MU by FCKBD square, then, if you know, then can you get P by FCK and hence P, and hence P means percentage of reinforcement. Tell the answer. Answer is yes or no. If you know the chart number, I told very clearly how to decide chart number. These two I thoroughly explained. You should know which is structural B, which is structural D. If you know that much, by computing PU by FCKBD and MU by FCKBD square, and if you know, from the chart, you first get P by FCK, then using P by FCK, you get percentage P multiplied by FCK. Is the answer yes or no? First. Is the answer yes or no? Answer is yes. That's all I want. Answer is yes. Now nobody should tell, I don't know this one, I don't know that one. Remember, nobody from this batch and RCC batch, others they can't tell me. Yes, answer you told is yes. Therefore good. Right. Good. That's what you are learning here. Now what you have to do is, our design is the column section, one chance 2400 with 70, 80, this longer side, along the longer side, bending of 70.82. Steel required is 1.5%. Other one, axial load with display bending. Steel required, see, even though bending moment is lesser, steel became more because the first bending is stronger. Because there, see, your first bending is, it has to overcome depth of 550. It is stronger. Second bending, it has to overcome 350. So even though bending is lesser, steel required more because this is weaker case. Clear now? Common sense. Even though BM is lesser, the column also is weaker there. So it became critical. So two answers came. Now considering both answer, therefore considering both cases separately, finally we considered both. Now finally what? Percentage of reinforcement to finally tell the answer, reinforcement to be provided. So that is, tell the answer, which one? 1.5% or reinforcement, finally reinforcement required, not provided. Reinforcement required is, tell the answer. One case you need 1.5% steel, other case you need 1.56% steel. So tell me, how much is the actual requirement? 1.5 or 1.56? How much? Actual requirement 1.5 or 1.56? 1.56, because higher requirement is right here 1.56%, that is higher requirement. Not over. Do not provide, because now IS code restrictions are there. I told you very clearly, restriction. As per IS code, anybody can tell what is the minimum steel? First answer. I am not writing fully statement. Minimum steel means minimum area of steel. Tell the answer. What percent? As per IS code, minimum steel, how much percent? You should not give less than the steel. You, for a column, should not provide steel less than that one. How much percent? Minimum steel. For any column, minimum steel, at least that much. 0.8%. 0.8%. Okay. And also, maximum permissible steel is 6%. Actually, 6% they told, but they advised not to give more than 4%, but ETAP's point of view 6%. Okay. Now, see, these all I explained for you. I am actually wasting time. I know it. All explained for you. Somebody here in the class should tell, sir, how many times you are telling, sir, what to do? Okay. Now, see. Now what you have to do is see the requirement. Our requirement is 1.56%. See, required is 1.56%. Therefore, tell me, what is the area of steel to be provided? Answer. You should not give less than 0.8. Yes, you need 1.56. You should not give more than 6. So, who we provide is 1.56%. Okay, lastly, remember, percentage of steel equal to 100 into area of steel divided by BD or divided by area. Substitute. So, therefore, area of steel required equal to whatever is the percentage into BD divided by 100. Actually, SP16 has given there. See there, SP16 has given there. Yes or no? They told, once you get the percentage, they told area of steel equal to 100 AS by BD. Tell yes or no? In the SP16 only, give or not? Once you get the percentage, they told area of steel is PBD by 100. Tell me yes or no? First. In the SP16 only, they told there, side by side, area of steel to be given is PBD by 100. You have tell yes or no, no. Tell me, yes or no? SP16 side by side, yes. Therefore, answer is 1.56 into B is any one. You can take any one B, any one D. Why? Because BD divided by 100 will give area of steel required in mm square. Area of steel required in mm square. That will come 1.56 into 350 into 550 divided by 100. It is 3003 mm square steel to be given. Okay, now my commitment to general public is how to design means how to find area of steel required for axial load with the biaxial bending. Uniaxial bending I told because before going to biaxial, uniaxial you have to cover. You will be knowing now why. Now, further steps I will continue in the respective class. How to give the steel detailing part, how many bars you are giving, where you are placing the bars, then some polygonal links will come. Lateral ties. What is the requirement of lateral ties? There is a condition. Diameter of lateral tie should not be less than 1. One is 1/4 the diameter of the largest longitudinal bar to 6 mm. And the spacing of the tie should not be more than 1. 16 times diameter of the main bar or 300, or other one is least lateral dimension of cross section, and between the two bars what distance to be maintained, what is the minimum spacing or what is the maximum limit measured along periphery for bars. When you place, the distance measured along periphery should not exceed 300 millimeter. Minimum number of bars is 4 for rectangle and square and 6 for circle. So many IS code requirements are there that all will come in the ETAB course when I go to building design, because I will explain to you detailing also there. Not once you get the steel, in the ETAB class I will tell you how to arrange the steel, how to provide practically. I will tell. This general class open to everybody is how to find the steel required. Someone will tell that also, sir. No, I cannot tell all those things. There's a limitation. My intention is what? To make clear the structural concept for everybody. Those IS code matters, detailing all, you should learn. For those who are coming to ETAB, I will tell you there. Don't worry. There, I will tell you later. A class will be there in the ETAB class where I will tell you detailing for beam, detailing for slab, detailing for column, detailing for foundation, where top bar, where bottom bar, how much bar has to be turned, all I will tell you, development length, etc. will come there. And minimum reinforcement, where you have to extend, everything will come. So for a general class open to all, I explained how to find area of steel or decide area of steel to be decided. Now it is what? Not structural engineering. Now simple what? Calculation of number of bars. How much steel is required. How you see, like this much is the requirement. Over. This is for axial load with uniaxial bending. Okay, now I will go to the most critical part. That is, these all are not coming for practical design. So don't think, then why you are doing it? No, these are not required. This way not required. You require axial load with biaxial bending. Every ETAB design, if you see, right click there, it will show you MU. I am calling MU1, MU2. ETAB will call it MU2 and MU3. My MU1 is ETAB's MU3. My MU2 is ETAB's MU2. I think that way. I am not bothered. I will see at that time, I will see the ETAB which one. See, crude I don't remember. And that I will tell you at that time. So there, you are not bothered. You don't right click. Some will tell in the class, sir, if yaar sir right click ಮಾಡ್ತಾರೆ, steel ನೋಡ್ತೀವಿ, ಕೊಡ್ತೀವಿ, ಮುಂದಕ್ಕೆ ಹೋಗ್ತೀವಿ. See, we decide the steel, provide and go further. Who will do post-mortem? Don't do it. But there may be people who are interested. Some column, heavy steel came. They may be interested. They will see, okay, let me see what ETAB has done. You can see all these things in ETAB also. It will tell you what is the minimum eccentricity, what is the L effective by B, what is the additional BM, everything it will tell you. What way I conduct the class here, same way ETAB will display. If you right click there, I will tell later. Okay. Now we are going to design of column with axial load and biaxial bending. I will write the heading here. Remember now, very, very important. This is very, very important. This what I am doing is, earlier, long back ETAB, see, long back, it is in maybe some 4 or 5, before COVID, much before COVID. I don't remember now. I had done a column design for the ETAB batch, maybe it is called ET7, I think, 6th or 7th batch of ETAB. I had done a design. ETAB is separate. Practical knowledge, I did a column design. And you will not believe, in the class, I did 10 trials, 10 times trial and error. That much not required. So that the number, IS code told, number should not exceed 1. I brought the number to 0.999999. Hata, bidolanta. That I will do one thing. I will search the problem. It is somewhere there. I will take the same numerical so that in the ETAB group and RCC group, I will send that notes to you. You keep it with you. In the class, you tell the answer from that notes. Because why? I am dead against for teaching of this type. See, this type of teaching I never do. See, this type of teaching I never do. But if you do independent question, what will happen is lengthy calculations are there, or therefore we can save the time. I will send in the group. So you have that with you. When I ask, I will give the same question. See, even I got the notes with me. I will write the question here in the next class. But now I am not, class is not over. Some extra principle is there now. So the design example, I will do 1 trial and 2 trial, then 3, 4, 5, 6 trial. I will write in the board here. At that time in the board, I will write. Or who knows, before the class starts, I will write full board, because other people, they don't have facility to get the notes. Notes only ETAP batch and RCC batch will get it. So others, general public, what I will do is, trial 1, trial 2, I will do it here in front of you. Remaining which I am not doing, I will write here. I will tell you, take that screenshot. After trial 2 to 9th trial, it is there. 10th trial, I will do it. Actually, 10th trial, you can do it. So now, I will come to the real important, that is design of real important for practical design. For practical design. Remember, the very purpose of you coming to this class is to learn practical design. Design of column, design of column, when it is subjected to axial load with, anybody can tell? With what? Tell me. Axial load with what? First, axial load with. Axial load with. Anybody can tell? Heading. Axial load with. Uni or bi? With biaxial bending. Biaxial bending, and practically almost 100%, because our class is E-tab and safe. If you go upon, if you design, see a column designed by E-tab, any column you see, right click, you can see MU1, our MU1 and MU2, E-tabs, our MU1 is MU3 there. Our MU2 is E-tabs MU. I don't remember, because why? I forgot now. The moment I see the sketch I can make, I don't have to by heart. Axis all, no problem for me. Just look at a bit. If I look there, I can tell bending how, about which axis. I don't require this way and tell the axis like this. If the BM is this way, that is the depth. That's all crude methods. I never require crude methods. Biaxial bending. Okay. Now, that is what? That is in the class, that is what? Structural knowledge class, it is like this. See, column section. First here, tell me, if I take this side as S2, this side as S1, if it is square, you are happy. Somewhere here is axial load PU, 1 BM this way and 1 BM this way. This is, and also remember, this is one of the, now see, both axes will come. This is axis 2, 2. This is axis 1, 1, 1, 1. And anybody can tell me what is this MU, what is this MU. Last chance for you. I will not explain second time. Why? How many times I have to explain? 100 times? Tell the answer. What is this MU? First, what is this MU? MU1 or MU2? See here. This is your axis 1, 1. What is this MU? First. MU, first. What is that MU? Tell the answer. I will not explain once again. Someone should tell, sir, if you explain, we are protesting and logging out. Why? You should tell, sir, we are not that much weak. But you cannot tell way, because if you tell that way, I know how to prove that you are weak. This is mu1, this is mu1, this is mu2, and tell me, for this mu1, for this bending about one axis, tell what is structural B and structural D. You first tell me structural D first. Tell me what is structural D for this bending first. You tell me for structural D, most important. What is structural D for this bending? See, this word nobody uses. Nobody uses this word structural B, structural D. They will tell, they will realize if they go to the class, this is the way to explain. See, so many people learn. If I explain this way, student will understand. Yes, that's why I am telling that way. They will tell, see, B, you know it, no? Okay. Usual. Structural D is S2 and structural B is S1. I will not tell once again tomorrow, next class. And for this mu2, tell the answer. What is structural B and what is structural D? Now leave it now. See, for this mu2, structural D is S1 and structural B is S2. Now, E tab, you don't worry, it knows everything. It is programmed there. Somebody programmed there. So in E tab, you don't have to worry. Suppose E tab gets confused. No, E tab will not get confused. If the person who programmed made a wrong program, E tab will give wrong result. Over. This is required. Now see, here we have to consider what? Combined effect of PU, mu1 and mu2. Combined effect of PU, mu1 and mu2. You have to consider the combined effect in single step, in one step only, or combined effect means one step. I should tell. Combined. Last time, Kesari bath separately eat, Kara bath separately eat, Idli separately eat, Vada separately eat. Now, Kesari bath, Kara bath now also separately eat, but Idli Vada now crush and mix. You know, sometime in some people, Idli and Vada, they mix both of them and eat, correct? That way. Last time what? Separately eat. This time combinedly eat. Single stretch. Load applied, BM applied, everything applied. Okay. Now, therefore, this is 100% required for practical design. Now, one important aspect, remember, see, one powerful note you are right. 1 minute. Feeling little tired. If you don't mind, I'll take 5 minutes rest and give the most important principle, because here what happens is there is a problem here. I'll tell you what is the problem. Problem is you require connecting bending moment. So I will tell you. So if you don't mind, suppose you feel already up here in hearing 9 o'clock, you told when non-stop talking is there, class I am not taking up 9:30. See, feeling tired, little hot today. Maybe 9:10, 9:15 stop. So almost approaching, why don't you continue? But physical strain is there. Shall I take some 5 minutes rest and continue? Don't leave the class now. Those who are serious, don't leave the class. If it is okay, I'll at least take 5 minutes rest, because finding difficulty for non-stop talking. I have been non-stop talking right from earlier. You are not answering. Yes, okay. Just you one thing. Meanwhile, you see all these things. I will tell you what is that one. Next time I am not going to tell. See, I will tell you something now. Your use of chart is in different way. I will tell you what. Your use of chart is in different way. Not like last time. Last time what you do? Last time you do mu by FCK BD square this way, PU by FCK BD this way. You get 2 points, get the intersection, get P. Now it is not that way. It is a reverse process. That's why before going to biaxial, you have to study uniaxial. Okay. Just matter of 5-6 minutes. You just go through this one, or you also take some rest, because otherwise too difficult. Okay, 5-6 minutes. the cutting. See, by next week, next Saturday, I will see that all these problems are eliminated. Which one? Laptop problem. I think there is something about rotation of the screen. There is some not setting. Actually, in Redmi, it is called lock orientation. That I think I am not able to correctly decide it what to do. That lock orientation is the problem. See, earlier I tried something. Suddenly, before the class today, one Mr. Tushar, I tried a trial session. He told laptop perfectly coming. Okay, then even today's your first session, laptop perfectly came. Then something happened when I reloaded it. Something happened. Turning was not popular. Not popular. Not proper. See, English problem. Not popular. Proper. Therefore, I told go through mobile at it. Next class will be I will put you Saturday. Next Saturday I will write column and footing. Title will be final part of the column, that is axial load with the biaxial bending. It will take exactly 2 hours to me, sufficient. So next Saturday class, column will be completely over. And Sunday, remember, double important. Why? Tell me. Sunday, double important. Those who want learn. This is the column, sometimes people manage. They got difficulty for which one? Tell me. Majority of the people, they find difficulty not for column they manage. See this interact diagram. Footing. That is where space problem, punching shear, two-way wide beam shear, and then that shear causing diagonal tension, bending this way, critical section, that all comes. But in the shape, everything taken care. Only one thing there, that two-way, one-way shear, shape will not do. Excel sheet to be prepared. In the class, I will tell Excel sheet. You prepare, in the group, I will distribute the Excel sheet. In the group, I will distribute. Once again, Tushar will do it most probably. He is an expert in doing Excel. So that, like see, earlier, deflection control. Because of the Excel, how easy in the slab, very easy I made it. Just a click, you get the check. Same way. Okay, now, come to, see, now, one note you have to write, powerful note. See, I am going to write now, I will dictate. You should write. If you are learning, some will tell, sir, write, sir. Why should I write? Slowly I am telling, you write. No. When we design the column for axial load and uniaxial bending in the bracket, that is what just now we finished. That is what just now we finished. We consider, we calculate PU by FCKBD, PU known, B known, D known, FCK known. And also you find MU by FCKBD square, MU known, FCK known, B known, D known. And then we decide the chart number and get what? P by FCK. P by FCK, and thereafter using this we get the P required. P required means what? Percentage of reinforcement required. Tell me, clear or not? This you take a sketch pen and write. What I dictated now, you take a sketch pen and write. Clear? You take a sketch pen and write that one. Clear or not? You take a sketch pen and write this note. Okay, now write. But Kannadadalli, Adare, Hindi, Magar, something like that, not Magar much. But, English but only. But, when we design column cross section, now I am dictating. See, when you design column cross section for axial load with biaxial bending, then we are not finding percentage of steel. We are not finding percentage of steel, because percentage of steel you can find only for axial load with the uniaxial bending. Then what to do? What to do is, the design is based on trial and error. Trial and error means repetitive steps are there. Trial and error. E-tab sometime will do 13, 14, 15 trials. It will tell you. Once I saw the E-tab, it told 15 trials I did and got correct answer. We are doing trial and error, where percentage of steel we are going to assume. How to assume, I will tell you when I start the design. See, how to assume, you write, he will tell in the class coming up. When he starts design for axial load and biaxial bending, he will tell first how to assume that percentage. I will tell you, don't worry. Okay. Now, here, when you go for biaxial bending, see, what you have to do is, see, here, this all you are right using sketch pen. Here, PU by FCKBD, no problem. This we get, because PU known, FCK known, B is known, D is known. This we get. Then, in the next term is MU by FCK into BD square. FCK known, B is known, D is known. This MU is not that MU. Not that MU means what? MU1 or MU2. This MU is not that action. Instead, it is the strength MU. It is the strength MU. There, it is the hitting effect MU. Here, it is the resisting capacity MU. So, this MU is not that MU1, MU2. This is something else. This is something else. What something else? You write. What is that something else? He will tell it in the next class. I will tell you, no, don't worry. I will make fully clear. I got my own way of explaining. Therefore, this MU we have to get. How? Using PU by FCKBD and P by FCK. But P by FCK is known. Tell why. Uniaxial bending, MU known, find P. Here P known, find MU. Clear? P, because PU is known, because we are assuming. How to assume, I will tell you later. So it is a reverse C. Now last conclusion. When you design column for axial load and uniaxial bending, find PU by FCKBD, find MU by FCKBD square, that given MU, find percentage of steel required. But when you go for design for axial load with the biaxial bending, then percentage of steel we are assuming. How? I will tell you. Then PU by FCKBD, same meaning. That MU by FCKBD square, that MU is not the given MU or MU to be resisted. It is MU that can be resisted. So reverse gear, or I'll write here lastly, or lastly remember, here means what? When we design column for axial load and biaxial bending, then we know PU by FCKBD and also P by FCK. Get what? Mu by FCK BD square. Get Mu by FCK BD square. And then using this, get Mu. That Mu I will call not Mu1, I will call Mu01 or Mu0. That Mu has some other name, some other suffix is there. Some other suffix is there. What suffix is there, I will tell you next time. Therefore, to understand, take a small example now. See, start. Very simple. Take a small example. Just imagine, Nodi. Just imagine. Example. So that ready for next class. Ready for next class. One example. Just imagine simply PU equal to 2000. Don't see previous question. Random example, but I will take the same thing. Reason is there. PU equal to 2000 kilonewton. PU. And B equal to 300 millimeter. And D equal to say 600 millimeter. And then M25 concrete plus FE 500 steel. And also imagine D dash equal to 52.5 millimeter. Imagine same way. Now what I want is for now what you require is what? Find PU by FCK BD equal, tell the answer, equal to 2000 10 to the power 3 divided by FCK 25 divided by B is 300, D is 600. Anybody can tell now only answer? Anybody can tell now only answer? Or shall I calculate? If you can help me, help fast. I don't know where is the calculator. I kept it somewhere. I see here. If you can help me, you can tell me. If you can help me, you can help me. No help. 0.44. Okay. That is 0.44. And one more thing. Just imagine P assumed is, this will keep on changing. P assumed is 2%. Just imagine P assumed is, or 2%. Okay, 2%. Now, PU by FCK over. Get P by FCK. P by FCK is 2 divided by 25 equal to point. ಬೇಡ ನಾನೇ ಮಾಡ್ತೀನಿ ಬಿಡಿ, ನೀವು ಕೊಟ್ಟಂದು ಲೇಟ್ ಆಗುತ್ತೆ. 2 divided by 25 is 0.08. 0.08. 0.08. Okay, 1 minute. Not 2%. I will take 1.8%. Irli, ಬೇಡ. 1.8%. Just for fun. 1.8 by 25. I want rounding off number. 1.8 by 20. Just imagine. Is 0.072. 0.072. Now go reverse order. You and chart number and D dash equal to 52. Heli, D dash by D. 1 minute now. Imagine your D is 600. I wrote it. So D dash by D equal to 52.5 by 600 equal to 52.5 by 600 equal to 0.0875. So we will take 0.1. 0.1 means M25 concrete, FP 500 steel, chart number 47. Chart number 48. I know it, 48. So therefore, from chart 48 for PU by FCK BD equal to 0.44 and P by FCK equal to 0.072. Find what? Find mu by FCK BD square. Mu by FCK BD square. BD square to be found out. Tell the answer. Start. Along the X line, if you don't know, see now, be careful. I will explain only once. Second time I will not tell. This all I am removing now. I am removing all this now. See, what you have to do is reverse. See, when you go for axial load with uniaxial, along X go for mu by FCK BD square, along Y you go for PU by FCK BD, intersection point you get by P by FCK. Now reverse. See, along the Y you go for PU term. How much? 0.44 comes here. Draw a line here. Draw a line here. Then, so many curves are there. Our answer is 0.072. So one of the curve is 0.08, other curve is 0.06. So 0.072 means 0.06, 0.08, 0.07, 0.07, see, 0.072 here. Then earlier see, locate this point, intersection get here. Now not that way. Locate this point, come down and tell me what is the value of mu by FCK BD square. Tell fast answer. Earlier see, locate the point here, go this way and intersection. Now not that way. Locate the point here, come this way and then come down. Number, fast. Tell me, whatever number you tell will do. Example, whatever number you tell will do, don't give nonsense number. Don't give nonsense. Where is SP16? At least reasonable. Where is my SP16? I don't know where I kept it. I don't know what happens here. Put this is ISCO. Somewhere I left it. Now I am not able to get it. Somewhere I thrown it outside. Okay, you tell the answer. Wrong also, no problem. At least tell a reasonable answer. Okay. Nanda Kumar told 0.09. Okay, agreed. Next time correctly will do it. Courtesy, Mr. Nanda Kumar. Courtesy. Okay. Thank you very much. 0.09. If it is wrong, you correct it. Don't make an issue of that one. Somebody comments, it is not 0.09. I'll tell you, don't talk that way. You tell me technical. Okay. Now, therefore, our mu equal to reverse. What reverse? See that 0.09 into FCK into BD square equal to 0.09 into 25 into BS2. 300 into 600 square. This is our mu. And this mu is nothing but our new name of mu naught will be there. I am putting a term called mu naught. Mu naught means strength. Answer. Tell me the answer. That's all. I stop the class. Get ready for next time. Next time I will see that laptop no problem, voice no problem, screen no problem. Today see no call, nothing. Why? Fully blocked. No, that block problem is overcome. No, screen inversion is not there. Today I managed to set the screen so that the outside disturbance is not there. Only problem today was that the screen rotating. I will rectify it this week. Next Saturday, I will do one thing. I will put a mark here. I will set the screen for that mark. I will put a tape here so that when I focus, I will see that I can know exactly how much I can use. Or in the pencil, pen I will mark here. See, boundary this way. Once the screen is set, I will remove it. Answer. You tell the answer and go for your dinner. 243, not 243, 243, 10 to the power 6 Newton millimeter is the answer. Now see, I will tell you one small important. Just make a note. This is something you are going to call strength later. Now see, reason all I will tell in next class. See now, one note you write here. If it is axial load with the uniaxial bending, Then PU is how much? PU is, PU is, I don't know what is the PU I told, 2000 kN, MU is 243, percentage you will get 1.8%. How? By marking this way, getting intersection. Now not that way. PU is known, percentage is known, instead of going this way, meeting here, you from here, you come here, come down, locate the MU point and get MU value. Tell me, fully clear? Next class, this I will not explain. I will tell, go back to last class, study and come back. My class is not meant for those who come for time pass or just visit. Okay, let me see. So many people are telling he knows little better. Let me see how he teaches. Don't come to test my teaching. Somehow I will tell, I do not want anybody to come and test my capacity. If clear means, okay, done. I will close the class now. Already 9:10. Next time, next Saturday, column will be completely over. So 10 trial we will not make. I will make 1 trial and 2 trial. Then you only will tell, sir, further we can do ourselves only. Yes. Then I will do one thing. Then from that, I will already send the notes to you. From the notes, I will write in the board and show the other people, public people. You will get the notes only, where in the WhatsApp group you will get it. Others will tell, we also want it. I will write somewhere there, maybe somewhere here, and focus there and tell, copy, take a screenshot. You will learn correctly. Sunday is a double critical class. That is the most difficult part or the most important part of the building design. That is foundation, by name only. If foundation is good, everything is good. If foundation is bad, everything is bad. Okay, thank you. I'll conclude now. So laptop problem, or don't make issue of that one. So little cooperation required. What all information I am giving, only people who have nothing to tell, people are that type, finding mistake. His laptop is not coming properly. In the classroom, you can see upper side something. Why should you see it first of all? See what I am telling here. Don't see what other things. So, thank you. I will close the class now.